Now let's see the exterior angles. Now that we have discussed about interior angles being the angles in the interior region of the parallel lines, exterior angles is the pair of angles which are in the exterior region of the parallel lines. It's very simple, as similar as the interior angles. So let's see exterior angles in the pair of parallel lines through the transversal. Exterior angles. Let me take the pair of parallel lines L1 and L2 with the transversal cutting the lines L1 and L2. And making 8 different angles with L1 and L2. Now clearly when we see in this, we see that angle 1, angle 2 are the exterior of a line L1 and angle 8 and angle 7 are in the exterior region of the line L2, wherein this is in the interior region of the parallel lines. So this 2 and this 2 being on the exterior region are called the exterior angles. To be followed with exterior angles are defined to be angles in the exterior region of the parallel lines. So here the exterior angles are angle 1, angle 2, angle 7 and angle 8. So here these 4 angles being on the exterior region are called exterior angles. Exterior angles in the pair of parallel lines. Angle 1, angle 2, angle 7 and angle 8. Now that we have discussed about interior and exterior angles in the pair of parallel lines, now comes the corresponding angles. So let's see what are corresponding angles in the pair of parallel lines. Corresponding angles in the pair. So let's take one pair of parallel lines L1 and L2. Let there be a transversal which cuts the 2 lines. Now for this transversal, as we already discussed about 8 angles which are formed with L1 and L2, we have 1, 2, 3 and 4, 5, 6, 7 and 8. Then the corresponding angles are said to be the angles which are correspondingly above lines L1 and L2. So if I have this angle 1, my corresponding angle with 1 is said to be angle 5. And corresponding to angle 2, we call 6 to be corresponding. Corresponding to 3, that is an angle which is below L1 is corresponding to the angle which is exactly below L2. So this is corresponding to this. An angle which is below L1, which is 4, corresponds to an angle which is below L1 corresponding exactly in the same region. So these are called corresponding angles in the pair of parallel lines. Corresponding angles are the angles which correspond to the same region. So angles which correspond to the same region are corresponding angles. In this case, angle 1, and interestingly, in parallel lines, the corresponding angles are equal only when the lines L1 and L2 are parallel. Therefore, angle 1 equals angle 5, which are corresponding, and angle 2, which is out here, is equal to angle 6. And angle 4, which corresponds to angle 8, are equal, and angle 3, which corresponds to angle 7, are said to be corresponding angles and are always equal. Therefore, I have a property which says L1 parallel to L2 is the symbol for parallelity. So when line L1 is parallel to L2, implies corresponding angles are equal always. Or always equal. So L1 parallel to L2 implies corresponding angles are always equal when lines L1 and L2 are parallel. Corresponding angles connected. Now that we have discussed about corresponding angles and all the corresponding pairs being equal in parallel lines L1 and L2, next comes the property of alternate angles. So let's see what are alternate angles in the parallel lines. Alternate angles. Imagine I have two parallel lines L1 and L2 divided by a transversal. Then we know that there are 8 angles which are formed with L1 and L2, which is 1, 2, 3, 4, 5, 6, 7 and 8. Now here we call the alternate angles which are on the vertically opposite side. So they are on the vertically opposite side, and this is vertically opposite to this. No, this is vertically opposite. So we have alternate angles which are alternate to the transversal. So clearly I see that this is alternate to this and this is alternate to this. So 3 and 5 are alternate, 4 and 6 are alternate to each other. So I have alternate angles to be angles which are alternatively in the region of either side of transversal is what we define as alternate angles. So have this angle 3 and angle 5 are alternate angles and therefore they are equal in parallel lines. The parallel line property says that alternate angles are always equal in case of two lines L1 and L2 being parallel. Therefore, angle 3 is 5, angle 4 is equal to angle 6, and these 4 angles are called alternate angles. And mathematically, we have the property which says L1 parallel to L2 implies alternate angles are always equal, is how we have the property which says alternate angles are always equal in case of two lines L1 parallel to L2. Alternate angles 3 and 5, 4 and 6 in the pair are equal in parallel lines. Now next is the discussion of vertically opposite angles when two lines L1 and L2 are parallel cut by the transversal. Vertically opposite angles in pair of parallel lines. Vertically opposite angles. Let's see what are vertically opposite angles. Imagine I have two parallel lines L1 and L2. Line L1 and line L2 cut by a transversal. Now we know that there are 8 angles as made by the lines with the transversal. Now vertically opposite are the one which are vertically opposite each other, as we have already discussed about vertically opposite angles. These two are opposite and these two are opposite. Therefore, in case of this vertically opposite angles which are opposite to each other, as can be seen, one is vertically opposite to 3 and they are always equal, as proved in the previous theorem. Vertically opposite angles are always equal. So 1 equals 3 and 2 equals 4. Similarly, 5 and 7 and 6 and 8 are all the possible pairs which are equal in parallel lines. These are vertically opposite angles. Therefore, when the lines L1 and L2 are parallel, their vertically opposite angles are also universally equal. Corresponding angles, alternate angles, and vertically opposite angles are always equal in case of two lines being parallel. Interior and exterior angles connected with parallel lines. Now that we have discussed various properties connected with two parallel lines and the transversal, now comes the most important property called interior angles on the same side of transversal. Let's see how this plays a vital role.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.